My name is Martin Perez, and I work for Intel in Finland for the Open Source Graphics Center. And I've been working on CI or testing related things for a while now. And today I would like to talk about standardizing the testing for Linux graphics subsystem. So why do we need to standardize this? Well, obviously there are benefits for standardizing the testing environment. The main point really is that the Linux UAPI mandates that it has to be backwards compatible. So you don't want to screw up the interface. You want to make sure that it keeps on that it's working as intended, and that user space is using it the way it's supposed to. So you probably know this XKCD, where that says every change breaks someone's workflow, and this is basically the problem that we have to deal with inside the Linux kernel, because, well, it's a regression, right? You cannot have any regression. So if someone cares about a certain feature and it is working in a certain way, even if it is a non-intended behavior, we have to keep this. So standardization actually can help. Sorry. So before going there, actually, so one way to know this better is to improve manual testing. The problem with manual testing is that it's very hard to document or reproduce, aka as a developer, I could do my testing and then say, okay, it's ready, and then send it. But then when someone else would be willing to test it again, they would probably test it in a very different way. And even if the developer extensively documented the test plan, you know, the results are going to be subjective. What one person could say is unacceptable, another one could say, no, it's perfectly fine. This is especially true for performance. And also manual testing doesn't really scale with the rate of change that Linux is going through. So that's the problem with manual testing. And then automated testing actually brings consistency, which is basically getting rid of the problem that I was mentioning, the hard to document and reproduce, and also the subjectivity of what is actually a pass and a fail. And, well, obviously, it is something that can meet the rate of change as long as you provide enough machines, but it's easier to buy machines than getting humans to do things properly. And so what it also provides is documenting the expected behavior and providing documentation on how to use the feature as expected, or which helps user space to actually do the right thing. And it enables the project to enforce that this behavior is working also in the future, and which is quite beneficial. So standardization really is helping. So standardization can be done on test suites. I guess that's the first thing. The objective is to make sure that drivers and so that the behavior is working the same on all the different drivers and also the different hardware generations. So for the kernel, we have one big test suite. This is the IGT GPU Tools, which started as an Intel project and started as the name Intel GPU Tools in 2009, and it was just INN15 related things. And actually, Eric Anholt started this, and he's not in the room now. Darn it. Okay. And it grew to become a test suite for Intel hardware, basically. And this focus extended to the entire DRM subsystem because some of the tests were hardware agnostic. So the hardware agnostic tests were reworked to run on other drivers. And then the hardware-specific tests got moved into a different folder so as to make clear what is actually hardware agnostic and what is not. And as of this year, it's IGT is now the official test suite for that is, so whenever you add a new UAPI for DRM, you need to document it, or not just document it, write tests for it in IGT. That generated a lot of discussion, but it got through, so good stuff. Now, what is not tested is the user space conformance. So an interface is used both ways, right? So, IGT is testing that the kernel is doing the right thing, but then we don't have a test for the user space to verify that it is handling it properly. So displays used to be very simple and dumb, so it was not a problem, but nowadays it is a bit more complex. You can, of course, hot plug displays, but there's also hot plugging connectors. With DPMST, you can share on one single cable, multiple screens can be connected to it. And the way it is handled in Linux is by hot plugging connectors. But you can also hot plug GPUs. And well, if you are a Wayland compositor and you want to verify that all of this is working, well, buy hardware and enjoy manual testing. Beautiful. Also, cables can be unreliable, and nowadays, because of the bandwidth that goes through these cables, you have actually a way for the screens to send a signal back to the OS. Hey, you need to redo the link training and try the different frequency, like different amount of lanes or things like this, which lead to, well, the user space need to know how to handle that. Also, we have a lot of hardware planes, which is a good way to reduce power consumption. But the problem is that they come with weird limitations. It can be memory bandwidth, or like the buffer can, if the buffer is in a certain format or has a certain tiling format, then it might not, for instance, be acceptable or allowed by the hardware to have it located at certain positions on the screen. I'm not kidding. Like, it has to be a position modulo of 2, otherwise it just doesn't work. So things like this. So basically, we need a way to check that the user space is able to use the latest features and is behaving correctly. And on top of this, we need to make sure that there is a graceful degradation in case some features are missing, or if it's exceeding the limits of the hardware. And so for this, we probably need to write a hardware agnostic test suite, and we could use VKMS probably for this, which is this virtual GPU that is just a CPU implementation. So that would allow us to test these sort of things. Now, hardware-assisted testing, that's something that is quite new, some at least in our subsystem. So to perform validation, we need to have hardware. We cannot just buy a machine and then be just testing it. So the first obvious thing is that we need to be able to boot the Linux kernel, so the one that has the new patches or the version that we want to try, and that may fail to boot. So what do you do in this case? You cannot SSH and reboot the machine, right? Okay, wonderful. So you need a way to cut the power and force it to reboot on a kernel that isn't working. And for this, we've been, at least at Intel, we've been using power cutters, and then grub reboot, which provides a fallback kernel when the previous one failed to boot. And this way we can collect the logs and then send a report to developers saying, well, no, didn't really work. And then for display connector testing, what we, so the screens are, as I said before, they are quite complex nowadays. They come with a different, well, a lot of standards, HDMI, DP, EDP, quite a few of them, and then all of them have different versions, and then you've got mandatory features or not. And these features are exposed through usually the EDID or some registers that you need to access directly. So how do you test this without having a lot of different screens and then inducing, again, like hot plugging on unplugging things and generating faults? Well, it's a little difficult. And on top of this, it's not just video that go through cables nowadays. You can have audio, USB, Ethernet, anything on top of these cables, especially DisplayPort is terrible for this. So basically, we need external hardware for validation. Fortunately, Google has made a platform to do this, which is called Chamelium. It's been used for Chrome OS validation for both, video, audio, or network. So it's working really well, and we got the integration in IGT thanks to Liud. Thank you. And then it got extended by Paul Kosialkowski and Simon Sir from Intel. They were Intel interns. And now we can actually handle most of the DisplayPort and HDMI conformance test suites. So this is quite a good improvement. Now the problems that come with it is that it's not cheap. It's about $500 per unit because it requires a very expensive PGA. The receivers that are there are quite out of date, so it's DP 1.1, sorry, not 1.2, and HDMI 1.3 and not even 1.4. I guess I did +1 on all the versions, sorry. Also, it doesn't support panels, so what you have on laptops, it's never DP or HDMI, it's EDP or DSI or other stuff. LVDS is probably gone now. But it also doesn't support Thunderbolt or Type-C displays, and if you want, even though it's open hardware, if you want to make it yourself, well, you need to get the receivers from ITE, and then, well, good luck getting the receivers as outside of China because of HDMI licenses and DP licenses and this HDCP, like, you know, content protection. So because of this, we cannot source the components. So because of this, this is not really suitable outside of the corporate world. So that's a little problematic for the open source movement, but at least there is something that exists, so it's nice. Now for testing infrastructures, it's all good to have the hardware and the test suite ready, but then not everyone is going to have all the hardware anyway, so we need to have infrastructures to do the testing and then integrate inside the development workflow. And we don't want to have every single project have a different way of reporting results. It's just annoying. And this is currently what is going on. We have quite a few projects that are reporting results. And the triggering point is different for all of them. The latency or how long it takes to get the results is also quite different every time. Then the test suites that are being executed are different. The architecture of the process or the machines where the run is made is also different. And to make it worse, the results are also coming in email or in web UIs that all are different. So yeah, automated testing is nice, but jungle of inconsistent reports is making it difficult for people to collaborate, and this is problematic. So we've been working at Intel to standardize the testing workflow and basically propose an architecture that could be reused by everything, and then have each box being swappable, so we can easily exchange test suites and execute things, or have different triggers that would be taken from different projects. So basically creating a new CI would be just a mix and match, and boom, here you go, as long as you've got the hardware, of course. But the point is really to help doing this. And we have a project on GitLab that is called Graphics CI/documentation, where we are describing what this standardization would lead to. And so in order for this to work, we need to define clear interfaces between the different points. And this way we can make it easy for people to share the code, but also for contributors to all the different projects to have some sort of consistency in the different ways you could have reports. And even though there might be some slight differences, if the concept is generally the same, it works. Like for instance with GitLab, well, there is just a green or a red thing, right? If either pipeline is fine or not. But unfortunately for hardware, it's a little more complex. So the problem with this is that, so how do we make test suite look the same from the executor point of view, so we can swap test suites easily? And probably containers are a good idea there. Then what result format should we use? Like, okay, well, Piglit is a pretty good one, but then maybe there's something better, or we would like to use something else. Then how do we identify known failures? Because, you know, Linux has a lot of bugs and known issues, but then how do you teach a machine to recognize what is a known issue or not? That's an important thing. So you can identify these failures by commit ID introducing the problem. So this is what Mesa CI is doing. And usually you would need to do some automated bisecting to get there. Or the way Intel GFX CI has been doing it is by filing bugs and writing filters that match the failures to the bugs. So this is a tool that I've been working on for quite a while now. And that is now open source, by the way. And another problem is that we need individual users to be able to figure out if their results are, if their failures that they see in their results on their machine are known issues or not. And so that means that we need a way to transport all of these known issues to the users. And finally, as I was saying, reporting has to be somewhat consistent between the different projects. Otherwise, it's just annoying and it reduces the involvement from developers to actually look at the results and try to understand them and see if it actually is a regression or not. Okay, well, that is it. I had a very short slot. Any question? Did you have one? Oh, okay. Okay. You probably need to get to the mic. I'm sorry. Sorry, Sean.
So are you still only running CI on the patches that have landed, and I think you're running them on Intel graphics mailing list patches, right?
So any patch that is sent on the Intel graphics mailing list is tested, and the IGT mailing list.
Are you planning on opening up that to DRI Devil?
Yes, but the question is how, and so there are some things. Basically, the VKMS would be helping with this. So we would, I mean, basically, if you don't need actual hardware, you could test a lot of things already with virtual hardware. And this is what VKMS would be helpful for, and Core could be tested like this. Obviously, we need to find a way to detect if, for instance, someone sends a patch for AMD, we don't want to test it on Intel if it has no chances of actually impacting things. So there's work to be done there, but the question is not whether we want to do it or not, it's how we're going to do it. And it's just a matter of time. We are in the middle of working on or changing our entire open source testing system to, first of all, really completely make it open source, and secondly, to open access to everyone to have them, well, to be able to look at the results properly, not just HTML files, but actually have access to the database and write queries and get all the power from the tool that we have internally, and not just the source code, but you also have the instance.
Yeah, you might be able to use get maintainers script to inform whether you should test the patch or not.
That is a good idea.
Because there's already regexes for all the various subsystems.
Okay. Yeah, well, that's a good point. Yeah.
You can credit me.
Okay. Any other question? Well, okay. Then otherwise, here are the list of the different projects inside the graphics CI part on GitLab's Freedesktop GitLab. And so these are components that can be reused for the CI systems. And actually, part of EasyBench has been reused now for kernel CI for the auto bisecting, because git bisect was not up to the task for it. So that's it. Thanks a lot.